the end of February 2025, we ran a Dial Shorts session that was one of the most exciting and fun sessions that we've done. And it was all about physical computing using Raspberry Pi hardware and with a focus on creating museum exhibitions. So Raspberry Pi and the Raspberry Pi Pico microcontroller, these are technologies that are used to write programs that control inputs and outputs. So we can attach all kinds of things to them, like buttons, buzzers, lights of all kinds, big, small strips of lights that flash, all kinds of things, screens, all kinds of inputs like temperature sensors, humidity sensors, distance sensors, movement sensors, all kinds of things like that. We can control motors. We've got some kits that build robots and things like that. There's an amazing range of things that you can do to make museum exhibits exciting, interesting, different. But also these things are finding a use in lots of other fields. As we were setting this up, somebody came along and looked at it and said that they want to use this kind of system to create write a program and create a system that will automatically water their plants when they're on holiday. That's fairly easy to do. So you just need a sensor that will check for the moisture in the soil, and then when the moisture is too low, it's going to activate a pump that pumps water into the soil. Very simple to do. Really, the limitation here is your imagination. It's quite amazing. We're actually seeing now people starting to connect these up with AI so that you can have responses to user inputs generated by AI quite easily. The equipment we're using, it's all internet enabled. Say more about that in a second. So you can see the setup here. It was a lot of work to do. Where I'm standing, I've got one of the sets that I'll talk about in a second under a camera. The camera is actually my iPhone, and you can see it on the big screen there, so I'm able to demonstrate live. And I'm also showing on the screen the code behind what I'm actually demonstrating on the device. We've got also some setups here. There's some Raspberry Pi 400s which are built into keyboards, and these really nice portable screens. So the screens are brilliant. They are USB powered, so they don't need mains power. You can actually run them off a USB power pack. And very, very lightweight, so you could Velcro them to a wall, for example. And then the Pi 400s are little portable low power computers, low power consumption computers, but actually very powerful computers built into these keyboards. More on that in a second. And you can see the kits that we're using as well there. So we had two of those set up, and two kits with set up to control the same kit but built into a robot. Okay, my inspiration for this work is there's lots of reasons, but I love museums. I go to lots of museums, and I have encountered some amazing interactive activities. Word of caution though, sometimes you encounter activities that started out amazing, and after they've been used by quite a lot of people, school groups especially, they're not working quite as they should, or perhaps not at all. So that's something to consider. But also the flip side of that is the kind of tools and technologies that we are going to be looking at here are really, really cheap, and you can make your exhibits or whatever you want very hackable. So the idea is we want people to tinker, try stuff out, and to support lots of creativity so people can try things. You can even, for example, have groups using this equipment to add activities to exhibits themselves. So it's quite a fun activity. We haven't yet used any of this equipment with schools, but we will be, and that's a really exciting prospect. I have to say, though, that we had, for this session, a range of people from undergraduates up to staff, established staff, and they were all finding it incredible fun and learning about programming, learning about technology, and being creative. There was quite a lot of cheering when they got things working, and that was a fantastic thing to happen. So back to my inspiration, which is museums, and I just want to talk to you about one in particular, and this is the Story Museum in Oxford, and they have this fantastic talking throne activity. So just going to cut away now to show you a short video of that in action, a bit of an explanation of what that is. It's my favourite interactive activity at a museum. There's lots of great activities. I particularly like this one. So here's a short video of the throne in action. You see you put the clothes on. That's not really part of the program, but it makes it more special. And then you select words from a rack, put them on this special board, walk towards the special throne, sit on the throne, and a dramatic voice reads out your words very loud. They sound like they're coming from those kind of trumpet speakers behind. It's a brilliant thing. It's so enjoyable. I'm not sure how it actually works. At first we thought it might be NFC detectors on the board, but I think actually they have a camera which is reading the words from this kind of perspective and then reading them out. So recognising the words and reading them out. It's a very enjoyable experience for children and for childish adults like me. So, physical computing. There's been quite a revolution in what we can do with this. What it's about is small computers or microcontrollers into which we can very easily plug not just conventional screens or speakers, keyboards, mouse, etc., but also we can plug in lots of small components, switches, buttons, sliders. The range is amazing, and they're very, very cheap. You know, you can get stuff just for a couple of pounds. Get big boxes of components for £20-30 off Amazon. Absolutely amazing. And one of the things it started with was the Raspberry Pi mini computer, which is a tiny little thing, and you can see that here. So about that big. But it's got quite a powerful processor and full connectivity. This is a full computer. It has a Linux operating system on it. You can plug a keyboard, a mouse, and a screen into it and program it and get it and run programs on it as well. That's pretty amazing. But it can also run off a external USB power source, so you don't have to plug it into the mains, or a 9-volt battery. As with the little screens that I mentioned, so these screens can also run off USB. They don't need to run off mains power, making them very, very portable. So in theory, we can build something and leave it embedded in a construction. So you might, for example, build a box with a screen and some interfaces, and just leave it running without it needing to be plugged into the mains. We can also take these out and use them outdoors or with school groups anywhere that we want. We don't need to have power. That's really impressive. So the Raspberry Pi mini computer, just going to cut away now and show you a demo. This is a program created by my son, who's 14, written in Python, which is the language that these systems use. They use a version of Python called MicroPython. Python is probably the most common language now in schools and universities. Lots of people know how to do this. It's a fairly straightforward introduction to programming, but as you'll see in a minute, you don't have to go that deep. There's a way of programming these things that is much more simple and user-friendly, novice-friendly. So we'll get back to that in a second. But here's a program, a little game created by my son. He's done it in such a way as he's created underlying libraries for reading what we call RFID tags. So these cards have little tags in them, RFID. We can put data into them. And also we have these little ones that are like key things. You'll see that in operation. So that's quite a cool thing you can do with these and write programs that use these tags. So have a look at this. I think it's quite nice. Hi, this is a quick demonstration of how you can use a Raspberry Pi with an NFC reader to read the RFIDs encoded into some cards and some tags. This is a very simple program. I'll show you the code in a minute, but it's the basis of the kind of thing that we can use to build interactive museum exhibitions. I've seen ones that are essentially this, but built a lot more professionally and robustly, used in museums. So here we go. First of all, we want the instructions. I'm going to take this tag.
Scan the cards in the correct order, then use the tag to check your answer.
Okay, so the first tag just tells us the instructions. That could have been a button that we pressed, but I've got the NFC thing set up, so I've just used a tag. So we want to scan the cards in the correct order. Let's see what we've got. So first of all, you can see the card has got a word or a phrase on it. We're going to begin with number 1.
I wondered.
I wondered. Well, that's surely going to be number 2.
Lonely.
Yep, we're doing well here.
A.
Obviously, cloud.
Cloud.
Okay, so do we think that's correct? I can now take tag number 4. And again, this could be a button that we use to input it.
Sorry, I wondered lonely as a cloud is wrong. Try again.
Oh no! Okay, so what's it going to be? Maybe they're being a bit funny here, so...
I wondered. Lonely. A. Clown.
Do we think that's correct? I wondered lonely as a cloud, so let's take the special tag again.
Well done. I wondered lonely as a cloud is correct.
Hooray! And we can take tag number 5 and...
Scan the cards in the correct order, then use the tag to check your answer.
So the next person can have a go as well and join in the fun. So pretty simple, but it illustrates some of the basic principles here. Okay, so as promised, let's have a look through of the code behind that NFC RFID card reader game. This was written by Alex. You might find it a bit complicated at first. You might not be interested in this, in which case you can skip past this section of the video and maybe come back to it later on. We will be looking at some much easier ways to get into programming, a block code approach, drag and drop, where you don't need to know all of this complicated coding language. But it's worth having a look at, and you'll get a sense of how clever some of this stuff is. So, where do we start? Right at the top. The way in which programs work is they start at the top and they proceed downwards. So what's called the interpreter or the compiler, depending on which kind of system you're using, reads from the top and it goes through the code downwards. So we begin with what are called imports, and this is just bringing in some library code some of which is the kind of basic stuff that you need to be able to do things with the Raspberry Pi. But also there's a bit of library code here called RFID detect lib. And this is some code that Alex has written himself that hides away some of the complexities of reading the RFID cards. So you don't have to worry about that when you're focusing on making the program do what you want it to do. That's good programming technique. So we've imported that, and we'll see some of that being used through the program. Then we go on to define a couple of global variables. So these are variables that are defined outside of functions that can be accessed anywhere else in the program. And those global variables are two strings, so text. We call them strings in programming. And the first one is an empty string called selected sequence, and that's going to be the container for the sentence that we build up by using the NFC cards on the reader. And then we have correct sequence, which is the correct sentence that we hope people will build. I wandered lonely as a clown, not cloud. Okay, so later on in the code, we're going to be comparing those two to see if the person built the right sentence. We've then got a function, so def startup message brackets colon followed by some code indented in. That defines a function, and that's a bit of code that doesn't run straight away, but only runs when we call it. And we can see it being called just below, startup message. The reason we put that in a function is because we actually call it in two different places. So here, we want to call it when the program first runs, but if you reset the program, I'll show you that later on, it's going to call startup message again. And what happens in startup message is, there's a very clever bit of code here, OS system F eSpeak. This is getting the voice synthesizer in the system to speak the words, scan the cards in the correct order, then use the tag to check your answer. The voice is a bit, it's not great, so we could replace that at some point with something that reads an MP3. That'd be much nicer. So startup message gets called, and then we're defining this sentence card bit of data here. And this is assigning, so those numbers are globally unique identifiers for each of the cards. Each card has its own ID, and we're assigning a word or a phrase to the card. And that's the same as is written with a post-it note on the card. And then in this, we have a little bit of code there, which will also, when a card has been chosen, it's going to read out, it's going to get the bit of text associated with that card and speak it with a voice synthesizer. And it's also going to add selection. It's going to take that bit of text and add it to our selected sequence that we're building up. And next we've got that function add selection, which takes that bit of text from the card and specifically says this is a global variable that we're using. And it's building up the sentence. So select sequence equals select sequence, what it was already, plus the new selection. So each time it does that, it adds the new words onto the end. We build our sentence. And then we've got another function called check sequence, and this is going to compare the selected sequence that we've built up with the correct sequence. And if we've got it right, it says, well done, your selected sequence, it will read out the sentence to you, is correct. And it will set it back to empty. Or if you get it wrong, it's going to say, sorry, read out your selected sequence is wrong, try again. Okay. But how does that happen? So when are we making it check the sequence? So we then have something that's defining when that's going to happen, digital key UID. For each of the blue tags, again, that's got a unique identifier. We're giving it a function and say, run that function when that tag is detected. So I think it's tag number 4. it runs check sequence. So when you put the tag number 4, it stops collecting your cards and compares the sentence you've built with the correct one. And if you use tag number 5, I think it is, it actually resets the whole thing and runs the startup message again, so you can actually try again. Or a new person can have a go. Okay. After that, a little bit of complicated code here that relates to, it's using Alex's library code to identify the tag and what of the methods should be used to process that tag. So the cards are all being processed by sentence card, and then we're associating some of the tags, the blue tags, with the digital key function, which either does check sequence or startup message. Finally, we've got there Alex's code for making the whole thing work, for getting the NFC reader to actually start recognizing cards and tags. And that's all hidden away inside Alex's library code that we've used. So there it is. It's not too complicated. I think writing this out, if you've not done this before, is pretty slow because you've got to remember what all these things are. But actually, to understand it, it's not too difficult. Now, in a minute, we're going to be looking at creating programs using a drag and drop blocks code approach, where you don't see all of this. But actually, what's happening in the background is that blocks code, drag and drop approach, is generating this kind of code, and then that's being uploaded onto the Pico or the Raspberry Pi. And you can, as you'll see, you can switch between viewing the block code and the underlying Python code. Okay, that's a good way to learn, actually, is to make programs using the block code and then have a look at what the Python code has been generated for it. Ways in which this could be extended, improved. For example, we've just used the built-in computer voice. I quite like that, but most people would probably prefer a recording of a real voice, so we can play MP3 files from this quite easily. We might do things like loading sentences and data from an external source. Obviously, we can have many more cards. Lots of things we can do with the physical setup of it, obviously, to turn it into a real interactive exhibit. And yeah, we can use switches, lights, all those kinds of things to extend it. Now, I have seen something similar where the sentences weren't pre-written on the cards. You could write your sentence on the card using a whiteboard pen, so it could be wiped off and rewritten. Put it under a little camera. Camera recognizes the text, and then the text goes into the system and it speaks the text to you. So all those different variations, a little bit more complexity in the hardware and the programming setup, but just use your imagination. That's what this is really about, is the technology allows you to do many different things, lots of different kind of inputs and outputs we can use, and lots of different types of interaction. You've got to use your imagination to make it worthwhile, and to think about how this gets your message, your idea across, and not just as a kind of fun, silly thing like this. Just to now mention a couple of ways in which you might see Raspberry Pi mini computers. They're often in these little plastic cases, which mean they're kind of a bit safer from damage when we're using them. And here's another alternative. So this is actually the same thing, the same Raspberry Pi, but embedded into a keyboard. We've got 6 of these, along with 6 of those nice portable screens. The key thing here is, so it looks like a normal keyboard. It's got the computer embedded in it, and it's got all of the outputs there, like HDMI to connect to a screen and USB to put a mouse in. But down here, we've got pins that you can connect things into. So you can actually plug the buttons, the lights, the motor controls and stuff straight into here at the back and use it in that way. We haven't been using it for that very much yet. We might do because we've got we're using these Raspberry Pi Pico W microcontrollers instead. So this is a development of the Raspberry Pi, but it's not a full computer. You can't run a full operating system on here. It's very limited. But what you can do is connect in all of those inputs and outputs very easily and give it a power source, which can be USB or could be a battery, and then load a program onto the microcontroller such that every time the microcontroller receives power, it starts up, it runs that program. Okay, this is amazing. These things are really tiny and even becoming smaller and more powerful, but with very low energy consumption. Okay, so these are fantastic for embedding into constructions that you make, exhibitions and things like that. Really quite amazing. They also, this is a Pico W. The W indicates that it's got Wi-Fi and Bluetooth on board, so you can load data in from somewhere on the web to be used, but also send data out over the web. You could use it, for example, as an array of sensors to sense what's happening in a room and send that information off to a central server, or communicate between the microcontrollers. You can do that using Wi-Fi or Bluetooth. And that's really impressive. Okay. So the Pico Ws that we've got are nicely embedded in these kits called Pico Bricks boards. This is really cool. This is kind of like a beginner kit for people just getting into doing this. And it takes away the need to do lots of wiring things up because the components on this board and the Pico W controller in the middle are all connected up already. You can then separate all the parts and use them to build some kits. So the kits that you can build are a robot, which can be voice controlled, a smart greenhouse kit, and a robot arm. And all those bits came with the kits. We've just so far built a couple of the robots, but haven't quite finished that yet because we're getting enough use out of the boards as they are like this. And you can see that we have a range of different inputs and outputs built into the board, including a motor driver for powering the wheels on the motors that power the wheels on the robots. There's an OLED display, an RGB LED, so we can make that whatever color we want, a button with a red LED, temperature sensor, relay switches for switching on other things on and off. This board here allows us to plug in thousands and thousands of different types of inputs and outputs onto there, all kinds of different components. Potentiometer, you're going to see that in a minute when I show you an example. Light sensor, buzzer, a connection for an infrared sensor, and they come with little keypads so you can put text and number input in. There's the motor driver. The kits also came with a whole load of other useful bits and pieces like a PIR sensor, soil moisture sensor, so you can do that, automatic watering system, all kinds of useful things. Gas sensor. There's some sciencey stuff on here like the gas sensor. There's a pump so that you can make sure that the soil is watered, an ultrasonic sensor and stuff like that. So a load of fun can be had. Now there is just an example of the kinds of things that you can buy off Amazon very cheaply, whole sets of different components and all of the wiring that's needed. So these components aren't like the Pico Bricks components that are very easily assembled. Here you have to do a lot more kind of little wiring of things. So it's a little bit tricky, a little bit more advanced. Frankly, I find it quite difficult because my eyesight's not brilliant. But this stuff is very, very cheap and quite inspirational. Okay, so next thing we're going to look at is how do we program? So how do we make programs to run on the PicoBricks kit specifically? With the the Raspberry Pi mini computers, we programmed those using Python. We have an editor, a text editor that we use to do that. And you can program directly on the microcomputer. But with the PicoBricks, we have to connect a computer into that, and we've been using the Pi 400s. So we connect a computer into that, and we need to run something that's going to allow us to do the programming. As I mentioned, you can do that in Python. So you can build a Python program, test it, and download it onto the Pico. That's what it looks like there. Okay, not so beginner friendly. Fortunately, PicoBricks provide this interface, which is a website. So you go to the web page, picobricks.com, go into the IDE, which gives you these settings. There is, by the way, a simulator, so you can try this out without actually having the hardware, and run this Pico Blockly, which gives you this interface. And that allows you, so on the left hand side here, we have all of the things, the components, so the bricks, for example, there's read button for reading in the state of the button. 1 means it's pressed, 0 means it isn't, and card ID for using the RFID NFC card reader. And write text to screen. So that's how we get things to the OLED screen. So it's got all of those things, and we can just drag and drop those components into our program and connect them up. The program starts with this PicoBricks starting block here, and then we do stuff. So it's got all of the components on there to use with the bricks, but also all of the programming elements. The logic, for example, there's an if statement there. If there's a couple of nested statements there, an if statement. So if read button equals 1, it's pressed, then do the next set of things. And then if a card ID equals 0, that means we're not scanning a card in. Else, we are scanning a card in and do these things. Okay. So it's drag and drop, and it just makes creating programs and testing them out very easy. We've got the the Pico W plugged into the computer by a USB cable. We can then connect using this option here and run our program. So just clicking on that will run the program on the Pico W, and we can see it happening live. And we can make changes to it easily, run it again, see what happens. Clicking on File allows you to save your program, open another program, but also to send your program that you've written onto the board so that it stays there. And when you disconnect the board from the computer, plug it into a power source, your program will run. Okay, independent of the computer. That's what using a microcontroller gives us, which is fantastic. This is so easy to use. So in the session, I demonstrated some programs and went through some of the code, but then we actually just had a go at the different setups that we had. So we have the NFC reader and a couple of cars and this multiple choice quiz running, and people had a go at those different things, and then they tinkered with the code, which is the way in which you learn this, by actually doing it. So what we want you to come away from this session with is some ideas on what's possible, and maybe some inspiration for you to generate ideas for what you might want to make. And then you can come along to us and work with us, and we can help you to build it and to learn at the same time. The best way to learn to do this is by actually doing a project with some guidance. That's the aim. Okay, so let's have a look at one of these in action. It is, in fact, not this one. It's another program. If I go down here. Okay, so, yep. There's a lot to this one. There's a lot of code. But what I'm going to do first of all is just show you it in action on the Microblocks board with the Pico W. and with some snippets of code in there just to give you an idea of how that works. So here we have a Pico Bricks board with the Raspberry Pi Pico W microcontroller in the middle. And various components connected to the board. This is like a beginner's kit. It's a good way to learn. And I've uploaded a program to the board. So this isn't connected to the computer at the moment by USB. The USB is just connected to a power source and it's giving the board power. There's also underneath the USB there's a place to plug in a 9-volt battery, which we can use to power the device as well. Okay, so we have a program loaded on here, and that program is a simple multiple choice quiz about capitals of African cities. The questions and answers and options are going to appear on this OLED display over here. We're going to get some feedback and some options to do things. So when we need to press this button to move on to the next step, the red light is going to show. And as the program's doing things, there's a little function called suspense that I've written, which plays a tone from the buzzer, a series of tones going upwards, and flashes that RGB LED, red, green, red, green. The RGB LED is really good because we can specify red, green, blue properties to create whatever colors we want. Okay, as the options appear on the screen, we're going to use this potentiometer here to select options. And there's the buzzer. So let's hit the reset button on the Pico. And it's playing a startup routine, that's the suspense routine there, and giving us some information on the screen here to tell us what we need to do in the quiz. Okay, so the red light's on, I need to press, first question is Botswana, so what's the capital Botswana? And the red light's on, so I need to press the button. And there's my options. Gaborone, Francistown, Mafeking. If I turn the potentiometer all the way to the anti-clockwise, I haven't got anything selected. The red light has gone off, meaning I can't enter an answer. And I get that low beeping sound rather than the high beeping sound. So I've selected an option there. Now I can press the button to give it a good firm press. My answer is Gaborone. It's given me the suspense. And it went up at the end, I think, and it tells me I've got that correct. Next question, South Africa. What are our options? It's obviously a trick question. Joburg, Pretoria, Cape Town. South Africa's got 3 different capitals. I'm going to put Pretoria because I know that I coded that in as the answer Not entirely sure that is the administrative capital, but anyway. Oh, fan press. Your answer is Pretoria. Suspense. Hooray! I got it correct. Next question is Namibia. Press the button. Now, I'll deliberately get this wrong. Let's choose Hansi, which is a small town on the Botswana-Namibia border. Your answer is Hansi. Oh, it went down at the end and says wrong, Do. So my score, I scored there 2. Very simple, interactive, physical computing using the Raspberry Pi Pico and a basic set of inputs and outputs, illustrating how we can give instructions to a user, give them feedback on their options, give them guidance on what they need to do using sound and vision.